Department of Microbiology here at Weber State University. I'm also Faculty Senate Liaison for the Environmental Initiative Committee. So I work with that group as well, and I'm happy to be here. This session is on soil and water restoration. Really? How? It's a great question. And to help us answer that today, we have Scott Dwire. We have, there goes my little cheat sheet. We have Scott Dwire, owner of Vortex. We have Jennifer Mitchell, who is the CEO of Naturasol. I'm saying that right. And we have John Webster, who is the Director of Communications for the U.S. Biochar Initiative. And so we want to welcome them. They have decided to mix it up a little bit. So instead of 3 separate talks, they're going to kind of do a team effort. And I think it's really fun. We should be getting done right at 12:05, and I'm going to keep them to that so that you can get out and get in line for lunch the fastest. All right? Great. I'll leave it to you.
Thank you. Thank you very much. Thanks for everybody showing up. She tried to give you a heads up that it is kind of inaudible. How many people were at the first opening presentation this morning?
At the keynote.
Keynote? Was that awesome? Mm-hmm. Okay, so we're going to wave a magic wand, and now you are the community. Okay? So instead of us trying to talk to you about our agendas and the things that we know, because we've got these two up here. John, how many years you got in biochar?
Just about 6.
And been on the National Council. He owns his own company, Go Biochar. If your interest is in biochar and all things that can do for the world, the environment, your personal garden, I don't care. He can talk to you about that, where you can source it. And so we're going to try to turn experts loose into the room and help you guys get the answers that you need to get. Jennifer Mitchell.
Fixing a doorstop.
You're locked in now, so nobody but
right
getting up and walking out. Jennifer Mitchell has been in the, I'll call it the biologicals, probiotics. How many people are familiar with that term? Okay?
Awesome.
It's been great because probiotic world for your health, gut health, and all that stuff. You guys, I know you hate this front seat, but it's totally fine. I've got some size 15s, and we'll try to not dance together. How's that? But the probiotic world, as it applies to soils, it's similar to your gut, and that's a great part. If your gut biome is operating right, you're healthier on so many different levels. So back again to the keynote speaker from this morning. If you think about this as a system, okay, instead of focusing on, like he said, the liver, and then trying to determine, okay, we're going to fix the liver, well, what about the rest of it? Okay, and so a lot of people that understand that probably understand the function that, I mean, this is a walking compost pile. Right? I mean, that's what's going on. I'm converting all the stuff that you would put in your compost pile, using bacteria to do it, and making those nutrients available for me as a critter. That's basically how simple that would work. So when we talk about restorative, we're trying to move from sustainability to restorative things, and how do we get there using the resources that we have. I'm representing the water quotient of restorative. So I've been in water since high school. I went to a National Science Foundation program, an interdisciplinary study of water quality in high school, okay? Summer camp for geeks, right? You had guys with slide rules. I mean, come on. So I've been in that arena for a long time. Part of it was my career, but my passion is there because without water, none of this works. Nature doesn't work, and the things these guys are going to talk about doesn't work together. But this is the team. So these guys are experts. How many people here have used biochar personally and put it on anything or in your processing? Fair amount, okay. How about probiotics or biologicals? Ooh.
Nice.
This is why I wanted to do an audible and call this and say, okay, now we're the team. So what kind of questions do you need to have answered? How can you apply what these guys, if there was some kind of this guy helped start X mission, so he should have
A data port.
a data
Yeah.
port. Sorry, we don't have that option today, but he didn't come with that. But that's the idea, is to try to turn that into. So I'm gonna try to.
There's some more.
Yep, there's some up here too if you want one. Easy to get to.
We can move in or.
We still have a chair there, a chair there, a chair there, a chair there. You wanna get a chair? We'll be glad to give you ours. All right, so I think where we need to start is that what you can't see can help and can hurt you. Okay?
No, it's what your boss doesn't know won't hurt him.
Yeah. So, anyway, so we're gonna talk about that because the stuff that we're talking about is in the soil. It's happening at microbial level, and it's happening in a way that you can't see. I mean, if you're in her profession, she can probably dial you right down to where that's happening at the root tip, etc. But there's a lot of magic that happens, and those two products play together. So I'm gonna give it to Jennifer first, and just kind of an overview real quick of how it interfaces, but a lot of these people understand that. And then you pass it on, and then we'll just start with questions and help these guys interface with you guys, okay?
Yeah, and I'm actually excited to see so many hands that popped up because a lot of times we talk about what we do and there's still a lot of education going on in the market about soil. We love things like Planet Soil, Kiss the Ground, Fantastic Fungi. Has anybody seen any of those films? Awesome. So when we can really see the soil and we see what's going on, we can tell that our soil is unhealthy right now. There's a lot of things affecting that. So if you have a project, be thinking about it while John's speaking. If you have a project or something that you're stalled on or something you're working on, that it's hit a wall, you know, there's oil or hydrocarbons in the ground and you can't get them out. You're dealing with mine site remediation. Maybe you have a property, somebody in your family has a property that's contaminated. Those are some of the specialty type areas that we like to focus on, while at the same time taking care of general soil and general waterway issues. And so for those of you that are familiar, we deal in microbiology, which means bacteria and fungi. So we mix both of those into our soil mix. It smells like cookies because the base of it is sugars. There's a lot of molasses in here, which is also great for the agricultural processes. But our mixture, and we have made it available for the first time, has hundreds and hundreds of species. And a lot of people will say bugs in a bottle don't work. You can't get them to stay in the liquid. They need to be crystallized. It's not true. And we've been testing product that we've had for years and years. And there is still just over 1,000 species in one of the mixes we have that's really old. So if there's a problem, now we can look at it and say, okay, which bacteria or fungi would help with that issue? And does our mix do it or not? So we don't have to go pour it in the ground and wait for a season to test. So that's a little bit about what it is that we do at NatraSolve. And John, I'll give it over to you.
Yeah, thank you. So my name's John Webster. I have a local company called biochar. We focus on taking waste stream materials such as wood chips, lumber residues, crop residues, things like that. We process it in high heat in the absence of oxygen to make something called biochar. I have these bags, sample bags that are next to the door. They're available for everybody to take. These bags are good for like 1 or 2 tomato plants. Mix it 2 parts compost, 1 part of this biochar blend, and you'll see a real difference in your plants. So real quick, when we stabilize the carbon that's in the source material, it has this structure. You can think of it like coral, if you're familiar with the pores in coral or the sponge on your sink. Except that it becomes a recalcitrant or a solid, and we can install that in any number of applications. The good news about this is it's simple. It's carbon. It's really simple. 5 years ago, if I said, hey, who's heard about biochar? Probably nobody in this room would have raised their hand. It looks like it was crazy, but now it's starting to enter the mainstream because this utilizes above ground resources in order to do better for the environment. Was part of the fire cycle, but we lost the fire cycle in many of our landscapes, and now we're bringing it back, but we do it in a way that is more efficient. Instead of having wildfires, we do controlled thermal conversion, and we stabilize this and we prevent it. We're disrupting the carbon cycle. We keep this from going back up into the atmosphere as CO2, methane, nitrous oxide, all the damaging greenhouse gas pollutants. When you incorporate this in soil, it does things like increases the below ground and above ground biomass. You see enhanced yield, larger yield on your cropping systems. You use less water, you use less chemical fertilizers. Less water, less chemical fertilizers, the less time on soil, the less compaction. This opens up basic things like water holding capacity, tilth. So this helps bring, it helps with so the biology can respire. So the biology that's under the soil for us, they're busy doing work year round. They need infiltration of water, oxygen, nitrogen, because we have a lot of crops that fixate nitrogen in the soil with little nodules and enhance the soil. If the water can't get in there, if the oxygen can't get in there, they don't survive and thrive. This helps with that. It also helps with the respiration process because they breathe out quite a bit of greenhouse gases. We incorporate this into composting processes. It accelerates the composting cycle by up to about 30%. If you use it in animal manure management, add it to dairy manure, you can reduce the methane emissions from dairy manures by 90%. It is outstanding. It's amazing. There's over 30,000 technical studies and peer-reviewed papers on this material, and nobody knows about it. It's hard to make money is why. This is hard to make money because after you install it to a certain amount, you don't need it anymore. Businesses do better when they can sell you something all the time. This, we sell it to you sometimes one time, and then if you're not telling your friends or your neighbors, we're not going to stay in business. It's hard. The other thing that's really cool about this is a lot of the systems that are used to produce this material, wood burns, right? Wood burns. Guess what? That's already an energy source. So instead of doing these like talking about nuclear to power DAC, what are we doing? We're using the existing embodied energy in a material to process and create and capture carbon. For those of you that are wondering about the carbon markets that you hear about on the radio, 95+% of those carbon credits that are issued on this material. Nobody talks about it. This is truly the underdog, and it's a miracle. This was developed by nature. As long as there's been spark and biomass and oxygen, we've had charcoal, we've had biochar. They got the name biochar in 2009 because they decided it was turning from agrichar, and they were like, we need to get something to identify the biological side, and so then biochar, and that's the term that's kind of stuck. And now we have things like biocoal, bio-oil, biofuel, so there's a number of different processes. The good news is that biochar is also highly configurable, so you might hear people in the industry say, well, it depends, it depends, it depends. We like to think more that it's all about the fact that it's highly configurable, so depending on the need, what type of carbon we need, we can do things, we can control the temperature, we can control the residence time in which it's exposed. So these materials at the high end are now being used for things in batteries. We can use it in plastics. We can use it in cement and asphalt as aggregate to decarbonize heavy industry. It's being used to inset and help people reduce their carbon footprint on their supply chains. It really feels like a miracle thing. There's an operation in Arizona. They do post and pole. So all the utility poles that we see outside, ponderosa pines, well, they were using $400,000 a year in propane to do their drying operation. They installed a machine that makes this. It's called a pyrolyzer. The process heat they put into their drying system, and now that $1 million investment is saving $400,000 a year in fossil fuel costs. This is all about being wise, efficient, and smart with what we're doing with our above ground resources. Why extract when we can utilize what we already have? We can even do things like process sewage sludge. We can carbonize it, harness the energy out of it, harness some of the nutrients out of it, and then we can make it so it's suitable for use with cropping systems. If you're not comfortable using it with crops, then use it with non-fruit bearing trees, shrubs, lawns, as aggregate and asphalt and cement. So there's any number of applications. Now, we are talking about the biological and the physical. So the biochar side has a negative charge, and a lot of those biologicals, they happen to love negative charges, because what happens is when you install the biochar in your soil and the nutrients come down in the water, that negative charge connects with the positive charged ions in a lot of those nutrients, your NPK, your water, and it forms a temporary bond. But while it's in there, it's still bioavailable to the plants and the biology in the soil. So you have water, you have nutrition. What does that mean? Survival and thriving environments for our ecosystem. That helps us with healthy trees, healthy plants, healthy cropping systems, and hopefully healthy humans that benefit from the advances we can bring into the agricultural and gardening space. So
Yeah.
that negative charge also, the reason that works is because it brings those biologicals in, and they start having their parties, and their bodies and their outputs all become fodder for the plants, and it builds the soil structure. And then it also acts as an excellent transport for things like probiotics. It's starting to be used in animal husbandry, and then also a lot of cropping systems, and mine site remediation, roadside controls of pollutants. It's really pretty spectacular. I'm taking up too much time.
No,
You wanna
that
like-
was great. We call it a bug hotel.
Yeah.
Biochar's like a little bug hotel. And does anybody have any questions specific, or anything that they're specifically working on? Yes.
Well, we talked earlier about the remediation that Ogden's gonna have to face with the rail yard.
Okay.
That might be a point to talk about. I had no idea that biochar could help with soil remediation, but
Yeah.
certainly natural solve can be good there.
Yeah, we've modeled actually a couple of sites, and we did talk about it, and it would be interesting to model it for here, because when you have hazardous material waste, as soon as you dig it up and take it off site, you're paying hazardous materials disposal, and it becomes really, really expensive. But between biochar and the biology, if we go in there and we mix it and we saturate to the level that they need remediated or that needs cleaning up, or if we have to dig up the dirt and turn it and just kind of make a slurry of the biology and the biochar and put that back into the soil, it's gonna come take those heavy metals and make them bio-unavailable and drive them deep into the soil, so they're not available for uptakes by plants, they're not available to animals, they're no longer on the surface. So that works in a wonderful way for remediation, and I think that's gonna open up a lot of land, like you see in Kiss the Ground. There's a lot of land that's out of use. But if we can go in with these and clean it up in months instead of decades, and be that catalyst for regenerative, instead of, and it is a hard business, because if you clean up the planet, or if you clean up a space like was talked about in the keynote, and it actually stabilizes the ecology, you don't need to go back and continue selling it over and over again. The bees come back, the plants are there, the soil's doing good. You might have spot treatments for things that you want to do, but you're not doing a consistent treatment like you would with chemicals. Yes, next question.
Yeah, I'm just curious in terms of the production of biochar. I know there's different methods, but what kind of air pollution does that produce?
So it's a very tightly regulated industry, and when I was mentioning the carbon credits, there's a complete LCA that's performed on every production method. There are studies performed by the U.S. Forest Service, the EPA, any number of groups, but in order to be in compliance with for the carbon credits market, because it's a financially traded asset, there's a couple of industries that are under very tight scrutiny. One is biochar, and the other one is the cannabis industry, because they want to know everything that's in everything. So we are held accountable for the emissions on bringing the material to the system to the pyrolyzer or the gasifier that's creating the biochar. So we have upstream and downstream emissions concerns. So.
Where is your pyrolyzer?
I had one, so I had mine in Salt Lake City. I was off 30th West and 900 South, kind of towards the airport, halfway there. I was buying my feedstock from a lumber company a half mile down the street. They made pallets and did some landscape products. So I was taking their waste and converting it. I did lose my lease. The landlord decided to sell his 4-acre lot for a lot of money. And so I recently just sold my machine. And now I broke, but I do, I've done work with different nonprofits related to biochar, but I also do biochar consulting and sales. I broker it nationwide. I can do it in US, Canada, and Mexico for all levels. So I can help you from getting things like sample bags to semi-truck loads. I have some photos. So this just has some, in fact, there's a truckload of it right now. There's some images on there from different things at biochar-us.org or biochar.org under the Learning Center, and we have slide presentations and things like that that are up there. I do want to clarify that I'm no longer with the US Biochar Initiative as I was introduced. I was at the time that I applied for this, but I've returned to the private sector to try and help make a difference in the material market and moving things. So.
Let me touch on your question, because one of the concerns you have if you see some of these biochar production, I went to India primarily to help with they have a process over there where they have what they call Kontiki kilns. Anybody know what those are? They're kind of bifurcated cone, slope sides, flat bottom with a drain in it. And you look at it and then they put, the cotton stalks or something from their last crop. They put them in there, they set them on fire. You're going, all those emissions, right? A couple of things to consider. One is they call that in India, they call that artisan char, okay? They too are regulated, but they have, as John said, they have calculated how much the carbon emissions is. Compare it to their current practice, which is they take that cotton stalk, gather it up in piles and burn it on the ground. When they start that all on fire, first of all, you're killing the soil microbiome, right? Anybody that's ever built a campfire realizes you just killed everything that was making that soil. It's now just dead dirt. And then everybody's burning their crop at the same time. And so it was like, you can't believe when that process is going on, everybody's farms are all burning their waste, how much is being released. So as they're burning it in this Kontiki kiln, the shape of it makes the bottom of the kiln not get oxygen. So it carbonizes it, and you can take these cotton stalks and just break them up, but they've still got structure. But they quench that before it has a chance to all go down to ash. So most of the carbon, even though it's being considered open air burning, is still contained in the plant material that's still in that kiln. They take that and mix it with sugar cane, what they call bagasse, or the plant material that's left over. That becomes their compost section. So it's biochar plus compost, and then add some active bio amendments. That's probably the best word to use. You've got a killer situation. In India, for example, that becomes another crop for the people that are actually working those fields. So now instead of burning it and wasting that resource, now they're turning it into biochar, and they're replacing, the government subsidizes, for example, the synthetic fertilizers. And if you understand, it's kind of like steroids. If you get on synthetic fertilizers, pretty soon you're hooked to it, and the soil just starts slowly dying. So the idea, remember, regenerative. And so I'm trying to help you understand that it's not, in the US, we've got a lot better ways to control those burns, but even at its worst case, you aren't turning it all into ash. So it's still stuff that you can incorporate into the soil, sequester that carbon, and getting the benefits from that.
Yeah, if I could point out that, we're kind of identifying stuff at the artisanal or the boutique level, but really the whole drive between organizations like ours is scale. Like the issues that are going on with our environment and the change in the climate, we have to accelerate responsible, earth wisdom wise processes, and we need to do it at scale, which is why it's such a great thing to see industry changing. We see fertilizer companies that are beginning to adopt a biochar because they realize when you apply fertilizer just in your lawn or in your cropping systems, they say don't water for a couple of days. Make sure it's not going to rain because you don't want to just wash it all out. They're finding that when they have a compatible carrier with it, like biochar, that has a longer duration in the soil profile. Because this does the most good when it's in the top 4 to 6 inches of your cropping system where your plants are. But again, this is all about scale. We need to go as fast as we can and as safely and responsibly as we can. And biochar is safe and shovel ready, and biologicals, frankly, are also very safe and project ready.
Let me address that in India so that everybody doesn't think, what they're doing is they're doing the very same thing John's talking about. We're partnered with some of those guys over there, and they're all excited because now they're getting biochar equipment that they can speed up the process, they can quantify and capture and control the burn. And there's a local group here that has the ability to attach carbon, I'm gonna use the word sequestration, don't get it confused with some of the other stuff that's out there, but basically using some catalytic conversion stuff. What comes out of the stack of a pyrolyzer can be reduced to graphene, water, and a little bit of extra oxygen, 99% of that. So you put that on the stack and now you've got basically carbon negative biochar. So those are the kinds of stuff that now you can scale and we can really start making a difference. And then you put that in the soil and you're keeping all those carbons and extra water in the soil. Amazing. You had a question, I'm sorry.
Yes, it was going back to when we were talking about the rail yard, how you said with the probiotics and biochar driving the heavy metals and hazardous material down the soil column. Will it just sit there, or is it gonna go into the a aquifer, into groundwater?
Yeah, excellent question. And actually the same.
Did you guys all hear that?
Excuse me, the same mechanism works in water as it does in soil. So if you use our product in water, it's going to take the heavy metal out of the water column.
Yeah.
If it's on an aquarium floor, it's gonna become a little bit of like a very fine topsoil that is benign, actually. If it's a waterway that's in the soil, say a canal or a lake or something, that heavy metal is gonna drive deep in the soil, but no, it's not going to become bioavailable again.
Okay.
So it's kind of like if you eat something, like he was talking about a walking compost or walking compost piles, once you eat something, it structurally changes it. And another way to visualize it is on like Cloudy with the Champs and Meatballs, if anybody saw that, the big blob that sucks things in, it's like a big piece of jello or something. So once it's the fungus in our mix is what does the heavy metal parts of the process. So once that fungus pulls something into their cellular wall, it's no longer released.
Okay.
If that makes sense.
Yeah.
Okay, great. What other questions? Back in the very back.
Yeah, I wanted to add to that, like with remediation, if you have some kind of contaminant or something you're trying to get rid of, I know it'll vary with tons of different things, but what's like a general timeline for how fast that?
Excellent question. So we have some really nasty stuff we deal with that it's almost immediate. Same with, what John was talking about with methane. So so methane is almost on contact. We did this really funny, I was just in the Philippines and we did this really interesting experiment, and we decided not to do it to you guys today, you're welcome, because we would go get poop from the piggery is what they would say. We're gonna go find our daily poop, and they would bring it in a bucket and bring it into the room and then open the bucket and everybody wants to run out of the room. Now you take a couple of drops, literally a couple of drops of our product with water, and you pour it on there, and the odor is gone immediately. And the whole presentation, we just left the bucket in there. People kept coming up and sticking their head in the bucket, which was hilarious to watch. But methane is almost on contact. Arsenic goes away. We're talking like days and weeks to some of the processes. Sometimes if it's really deep and you need to get to a deep level, the processes will take, months or years if you have to dig up a lot of land, but a lot of it's happening immediately or, within a couple of weeks, a couple of treatments.
Also,
And-
there's
yeah.
plantings that you can put on those contaminated soils, and certain plants are really good at uptake. And so now you've got contamination and you're using nature to remediate those soils, and they go deeper and they send their roots down farther, but you aren't pulling the roots out. So now those roots are taking the contamination even deeper and tying them up in the plant material itself.
And similar to biochar, it takes a lot. It takes truckloads of this to really scale like a business level, but it doesn't take very much to work. So 1 ounce of this will do between 500 and 5,000 gallons of water, depending on what's in it, and 3 ounces will do an entire acre. And if you're treating your yard or something, say you're gonna use it 3 to 6 times a year, depending on if you have horrendous soil like down in Navajo Nation, or if you have better soil like in Florida that's humid. If it's humid, there's already moisture in the environment, these guys are a little happier like us at the beach. When it slows down or is colder or there's no water in the soil, then you're gonna use a little bit more. But it's, the combination between the two, especially in remediation, I think that's gonna become a wonderful place to play because there's a lot of sites that need it and things that are speeding it up and do not need to continue, and with what Scott was saying, if you can put in crops and plants, that's what the natives used to do. They had everything extensively landscaped to handle their processes. And so all we're doing is inviting nature to go back into those spaces to clean up. So we don't have to go back to the pilgrims to have industry run how it does. And we don't have to deal with waste piles. We can just run alongside industry and clean up the things that happen as a result.
Yeah, and on the biochar, real quick, on the biochar site, this product doesn't move that fast, right? You want to think of biochar more as that baseline, that super strong foundation. The things that it does in remediation is it's complementary to the biologicals and the phytoremediation efforts. But what it will do is it helps to prevent erosion. So if that soil is holding more moisture, what do you have? You have less dust from the drying events, which means you're reducing the amount of potential contaminants to the local environment. You reduce the impact of erosion events. So again, it's all configurable, right? We can configure it as to what we need to do and then target those applications. But it's when you pair things, the biology, the plants, the biochar, general soil health, compost, you can really do it can feel like magic, it really can. It's fantastic to be involved with such a thing. But, and again, it's all backed by science at this point, so.
We help nature do what nature does best. Nature is restorative. That's the systems that nature put in there. If you have a patch of bare soil, it will figure out how to put something on there that'll work. And it's pretty amazing. And so all we're doing is saying, hey, these are ways that you can create a restorative system that nature can then take and work with it. Like you said, 18 months. Go ahead, I'm sorry.
Where do you source your biological components from, and do you have any considerations or concerns as far as the introduction of non-native microbes?
Also an excellent question. Yeah, a lot of people worry about that. Especially during COVID, just go out and tell people you're doing a business where you want to put bacteria into their soil and water, and everybody's, got their masks and their gloves, and, it's like, awesome, this is gonna go real well, And so getting through that time was interesting, but I found now with the advent of prebiotics that people are taking from the grocery store, a lot of people are understanding that we have bacteria, we're mostly bacteria. So there are some, and scientists don't like the term beneficial bacteria, but that's something I say, because if you have bacteria that's doing a job, say it's cleaning up hydrocarbons, it's going to be active, but when it runs out of food, it's going to die off, or it's going to become a food source for one of the other bacteria strains in the chain and have enzymatic reactions and those types of things. So no, we don't have any bacteria that, and ChatGPT is also great. We went through and fed all those into, AI, so we could come out with another third-party resource to say these are beneficial for the environment and for human health. Now, if you take it and you shove it down your nose, that's about the only way that and it's because of the molasses. It's actually not because of the bacteria and fungi. But you can eat that. I mean, I do it all the time just to prove a point. But and the runoff. But we have done those studies. For a very long time now. We've been watching the downstream effects, and it's exciting. There's a place up in Park City called Pace Ranch, and it's a trust land. The guy that developed it, he owned all the land that became Park City, and so he felt real bad because as soon as he sold it, they just started building, and it was encroaching upon all of the native and community-based areas where people like to go hike and walk around. So he turned this land into a trust land, quickly went downhill because he was using chemicals for everything and just polluted everything, killed everything off. And we went back up there and were able to restore it. And we did that in two years. All the waterways, all his 97 acres of pastures, he didn't have to buy feed anymore, so we're cutting down on emissions for transportation. His land, his ecology got restored, and now Park City gave him more money so we can expand the waterway. And people are allowed to go up there and use the side-by-sides or go camping or hop in there with the kayak. And before, nobody was using it because it was gross, and now it's beautiful. And there's a crane that lives up there, and all the duck hunters are mad because all the ducks are over in that pond. But the restoration part of it is, the point there, and the downstream effects are beneficial, not harmful. Yes, sir.
If this is open forum, I'm interested in more about this in the water context. So could you talk a little bit more about what are the different situations or contexts that you see for the water remediation, and maybe just some situations, but the different situations or contexts and approaches and things?
Do you have a specific project you're thinking about, or a specific context that?
Well, I want to know the range of contexts that you work in.
How many more minutes do we
Yeah,
got?
I was going to say.
Between biochar and biology,
Yeah,
you've got a
wow.
you can do it at all levels, from
Well,
survival
perhaps
to
ones
commercial.
that would be
Even tired
closer to, say, industrial or local government projects.
Yeah,
Yeah.
okay, perfect, because that's the kind of stuff I've been trying to find solutions for. Used to be a general contractor, and if I showed up with a tool belt, I could help you a little bit. I had a trailer full of tools, okay? If I have subcontractors and they've all got trailers, we got you covered. So that's how I approach projects. I don't try to do a one size fits all. As John said, highly configurable. And water has a lot of, we've still got the same water that we've always had. So why are we running out of water? That doesn't make any sense. It's the same amount of water that's been on the planet forever. But some of those restorative solutions that water normally has are broken. And so we're trying to augment those. So for example, if you were doing a highly contaminated site, I'll give you a prime example. We were working with the strawberry growers in California. They have sucked so much water out of that aquifer that they're pulling in brackish water because they're getting seawater intrusion into that aquifer, okay? So we're coming along and we're trying to use biochar, and we're trying to use biologicals to stop the use of fumigants and fertilizers. And fumigants means they're spraying so that they kill all the soil biota completely, cover it with plastic, and then plant their crops through that. So not only are they degrading the soils, they're killing them, and then they're watering them with brackish water, and they wonder why they could only get 2 years crop out of that. So we came along, we were looking at all this, but we were trying to figure out how to solve the brackish water problem. okay? Both these can help with the soil, but if you can't stop that, what do you do? So we found a product, a system that basically uses low temp, low energy distillation. And you can now distill, so you can distill the salts, and the more fertilizer they put on, the more salts are actually being applied to the soil, because a lot of those things break down into salt components. So you can probably explain how that works. But my point is that we were trying to solve that issue. Now you can take that same solution that we were using on the crops, and you can apply it to other places where you have worse contamination. So sometimes you have to step outside of I'll call it the natural systems, but basically that's all we're doing is we're taking the normal rain cycle, we're converting the water that's contaminated, we're distilling it into and recondensing that water. Out comes distilled water and the contaminant. So we can take almost anything you can imagine and convert it to that system. So if you have something that's really, really toxic like that, there are solutions that can go all the way down that path as far as you need to go. A lot of them you'll find, it'll surprise you, what you can do with these two components over here in water, and clean it up that way. But if you need to, we can take it all the way without extra energy, a lot of extra energy.
And I'd say nutrient runoff is one that's become really popular also, and I know that we both handle that, but our waterways, I mean, if you go look at the lakes around, I mean, everywhere, they just look absolutely terrible. And they're not, and if you go clean up the lake, but the farmer down the street is still using chemicals, or the, abatement associations are still using pesticides, we're just gonna be cleaning that up again. So using solutions that allow the ecology to restabilize and stay healthy and continue to deal with increased nutrient loads is another area that's been pretty popular. I think there was one other question too.
Maybe just one example that might be closer to home with audience, like a cyanobacteria or blue-green algae, what it's called.
Yeah, maybe everybody at the Utah Lake Commission and everybody associated with that product process knows who I am. I actually have taken the floor and stood up in front of the legislature. There's so much we could do there, and we could actually use the waste. There's like, I think it's 11 municipal waste plants that dump into a lake that's 10 feet deep. I can't imagine how that would be a problem. That's so weird. And then it runs all the way down the canals, and people's secondary water in Jordan Canal are connected with that, and the farms started dying a few years back. That's so weird. I can't, imagine. And we could go in there and put systems in place for the runoff that's coming from the farms, systems in place to deal with all of the waste as it comes out, and that would actually become food for our bacteria and fungi. They would love it, they would thrive, and we wouldn't have to dredge a lake, we wouldn't have to empty it and kill every single thing in it, which is one of the proposed plans. So yeah, close to home cyanobacteria is nasty stuff, and being able to deal with it at its source instead of after it's a problem is.
That's what McCoy is doing.
Yeah? It's a good point.
They say they don't have the technology to clean it up.
Yeah.
Yeah. You had a question?
Does your product work in saltwater as well as freshwater?
Oh, that's a good question.
We have a saltwater mix that we developed specifically for a large aquarium, and so there are bacteria and fungi that will work in saltwater that don't dehydrate. Yeah.
You have a contact information that we can contact you guys later.
Yeah, we'll
So,
have some stuff at the end of here. Yeah.
One of the things we realize is there's lots, we've got a timer
We
here.
have 5 minutes.
About 5 or.
And so we have 5 minutes, and so you'll see URLs. I'll open this one up here in a minute, and you can scan that information. There's a little questionnaire there, so we can steer you in the right direction, because we've got kind of 3 specialists here, although we all overlap, you can tell. We love to create synergies. We're hoping that this group right here will go out, start applying some of the stuff that you have learned today. Be hungry for more information. When all of us started, we're like pioneers coming across the prairie in hand carts, okay? We want to empower you, particularly the young people out here, to be coming across the prairies in, you know, speed cars, you know, whatever. I'm trying to keep it green.
Yeah.
I'm like, wait a second, a hand cart's pretty green. I can't. Anyway.
A really nice bike.
Yeah.
Yeah.
Really nice bike. Air conditioned blowing in your face. But that's, so the amount of information that they get, these two, well, me too, can't get to is a lot.
Gathering.
So we love to engage with the community. We love to engage with those people who showed up in this room, because we know this is the nucleus of some amazing things that are gonna happen. And using the information that we have and the products that we have will allow you to really dig in and do a lot of good in the world. So we're talking, I see people out here involved in islands. We got people asking about Utah Lake. We got the Great Salt Lake. And so we've got people representing both local and distance. So get your questions answered. I'll put this up on the screen. Anybody got any more questions?
I want to take 2 minutes to do a little soapbox, because this is really important for all of us to survive. Soil is utmost critical, and what I want to drive home is it's time to demand systemic change. It's time to demand systemic change. Investments in simple things like this. Biochar, you know what that is? This is an investment, not a cost. It's an investment, not a cost. It's an investment and not a cost. Now that I said it 3 times, you'll remember that biochar is an investment and not a cost. So when you're talking to the city council and demanding that they find a way to keep the parks green but with less water, biochar to take care of the soils, and you have green lawns in the parks. Let's have green parks. There's no need to save water there when we can just be water wise and carbon smart for our soil health, right? We can do more, we can do better, we can be the change. You can demand that the cities and the government spend your money in wise ways. Be practical, be smart, voice your opinion, because that's what makes it different. Vote your conscience, things like that. Anyway, I encourage you to look into biochar practices for your home, but again, systemic. You know, you have a favorite yogurt, say, hey, what are you doing with manure management for the cows that are making my delicious yogurt? How are you accountable? I want to know, is your dairy pushing effluents into the estuaries? Oh, if so, why aren't you fixing that? You're responsible for that. I demand that. I want to keep eating your tasty yogurt, but you have to meet my needs, because I want more from you. So be the cog. Be the step in the wheel.
Huge
there.
point. When I started dealing with cities and counties in the states, I really thought that they sat around and had like an objective and they would go search and find an answer. What I quickly found is they actually just vote on what we bring them. So if the only people in the room are bringing them things that are terrible for our environment, but they're making sure they're in that room, we don't have a chance. We need people in their own cities, with their own water bodies, in their own communities, outside of their own stores, their own developments, to be demanding that we use things that are intelligent and don't just completely ruin our environment. Because if your neighbor's doing it, your county's doing it, your city's doing it, it's ended up in your water.
City council member, 12 years, you are absolutely correct.
Nice. Well, good on you too. Thanks for that.
Thanks for being in the room.
Yeah.
Because,
Not currently council member. I'm
like, do you understand
got some common sense and retired after.
but you understand the systemic problem. And if you think about us as part of the ecosystem, okay? Our communities are the ecosystem, and we are sentient beings that can affect our own ecosystem. That's an exciting part, because that puts the power back in your hands, okay? Sure, we've got tools, okay? But if they aren't implemented, sorry. I mean, she stood up in front of the people and said, I only have one question. How much is anybody gonna pay my bail when I put my biologicals in Utah Lake and it fixes it without permission, okay?
Yeah, everybody in the room is, you know, they're trying to figure out how to clean it up, and I've been in there for about 7 years now. All the people that were gonna build islands, talked to every one of them. And then it's years and years and years later, and I'm asked to go to this event, and yeah, just walked straight in front of them and said, if I get arrested, who's paying my bail money? And a lot of people were willing to do that. A lot of people are still willing to do that. It's just, I had to make certain arrangements and agreements with my team so that I don't do outlandish things. But, you know, we're even talking about doing things like going over large land masses and spraying our logo or somebody else's logo into it. Because if you put says biochar in there, you put my biologicals, and you paint a big logo, we're going to be able to see it from Google Earth real fast. So if people want to clean things up, yeah.
A quick comment to end with. So one of the biggest concerns we have in the Wasatch Front is the air quality that's coming from the dust that comes off the Great Salt Lake.
Right.
That dust has arsenic and other heavy metals. Won't your product help with this? Could
Yes.
it realistically help?
Yes, it will. And I think there's a reason that they do not actually do that in mining, because if you lock up all the heavy metals, you can't extract them for money. So if we deal with that toxic dust, yes, but it's going to have other effects that other people might not be loving.
Food for thought.
But
No,
yes, it would.
So you've got lots of people, students, other educators and scientists, okay? That question he just asked, okay, is key for our airshed in the valley. So what can be done with natural systems to lock those contaminants into the soil? And that's cyanobacteria that's acting up too.
Remember to take your samples. If you want a real interesting podcast, that top QR code on the way out the door, scan it. My contact information's on here. Please scan this and take the survey. We have cards and brochures up here as well. Thank you, everybody.